So let's see here. We're going to move right in. First off, I am very presumptuous. So I'm going to tell you that this didn't work the last time you tried it. So, because mainframes have been around for a long time, and I've never heard anybody refer to a mainframe except to say, we need to get rid of this. And so you've tried this before, and it didn't work, or at least it's still around in great substance. And then we're going to look a bit at some of the constraining factors. What does it mean to get off the mainframe? And then the importance of flexibility and scalability in your target solution. That's absolutely key in this. And then finally, we'll look through a policy domain example to see a little bit about what some of those factors turn out to be. So some of the driving forces in this, of course, cost, right? Everybody looks at you and says, MIPS cost, we're here. It's a relative thing. Have mainframes gotten actually more expensive, or is just our expectation of computing gotten so cheap? Because they cost relatively more, but we expect computing to be like nearly free, and mainframes cost. But the other thing is this expectations of availability. Modern applications are not tolerant, or modern customers are not tolerant of downtime in applications. This is not something that the business wants to hear about. Mainframes and typically mainframe databases will require downtime to make structural changes and stuff like that. They're kind of hard to move into multi-region capabilities, because they're not essentially a clusterable thing. And then finally, everybody talks about the 7-layer dip model, right? In order to get that stuff out of your mainframe, you've got a whole bunch of layers in between. So this is really, let's say stacking up things, but driving the need for change. So I bring in a little light example. We got the Princess Bride here. And note the way Wesley refers to it. Nonsense, you're only saying that because nobody ever has, right? And so here's my prescription for mainframe offload. Not that anybody's ever succeeded. But that's because there's a lot of perils to mainframe offload. So if we think about in the Princess Bride, they're going in the fire swamp, and you're walking along, and the flame shoots out of the ground, and you're burnt. Right? But imagine that this can happen to you, right? There's things out of your control. You've got the whole project planned, and your mainframe team goes, not installing CDC, sorry. And now you're left with batch files. So the next thing, the lightning sand, and this is something that we do have some control over, and we'll see a little bit about it. But in this peril of the fire swamp, the lightning sand is the more you struggle, the deeper you go in. And that is akin to the planning problem. Mainframes are complicated. Mainframes have been around a long time. It is really presumptuous to say we know exactly what everybody through the generations of people who wrote code for that mainframe were thinking. And so and in this insurance example, somebody's going to ask, have you thought of everything? Is there anything, can you guarantee me there's nothing you've missed in this plan? And the answer is never. You can't do that, right? So this strive for perfection, for this, ultimate design that's going to embrace all those pieces, might be the killer of your project. Because if you're waiting around to get the perfect piece, or waiting around to understand every aspect of it, you're never going to get there. And then finally, these rodents of unusual size, reorgs happen, budgets shift, things like that. So there's a whole lot about doing a mainframe offload that can hit you out of your control, and you don't have a lot of time to get this thing together. So everybody knows big companies, budget cycles, change is constant. We spend 8 months a year trying to finish the project that they're going to decide if we can actually do next year in the next 2 months. And then we spend 2 months in a freeze where we can't do anything. And then we start all over again, maybe with completely different priorities. So if you can't go in and demonstrate value quickly, your project is toast. Because really, it's a popularity contest for funding. And how do you get popular? You deliver great features to your business, right? So how would we do this if we were going to offload to a SQL database? So I've got some, simple steps across here. And when you look at it, of course, we've got to get the data off the mainframe. We've heard a bit about CDC, and we know that Kafka or Confluent is excellent for data movement. So you got to get that data off of the mainframe. But then in a SQL world, you have to plan every single field, every single table, every single piece of data that comes off that mainframe has to have a predefined resting place. And that's part of that data modeling operation. And when you look at your mainframe, you think of all the crimes of the past, you say, well, we're going to fix that. We're going to make a slightly better design, for our tables. We're going to have it a little bit better. So you bring that stuff in, you build a whole bunch of DDL operations so that you can have this data, these ready-made spots for all the data. And then these transformations so you can correct the sins of the past. And then you can get that data into your database, right? And then finally, you've gone through all this effort to spread that data out into this big relational model. And now you got to pull it all back together to deliver a nice API payload to someone. So I've made an attempt here with these bar graphs to say what's the relative effort in that. Pick a unit. I can't even give you, is that sprints? Is that, but the point being that data modeling is costly. DDL operations are costly. And it's also very costly to assemble all that data into a performant API. And this is where people are like, oh, we better use a stored procedure for that. We need a materialized view for that. We got it. And so all of that stuff comes in. But in contrast, if we did this type of cycle, and remember, we want to get this stuff out fast, because if we can't demonstrate this by October, is it October? It's October. And so then we're done, right? We're not going to be able to get there. So in MongoDB, a lot of the steps look similar, right? We come off of the mainframe. We got to have our data movement strategy. But you know what? You don't have to define rigidly where that data is going to land. Whatever comes off that Kafka topic is going to land in MongoDB, and it's going to take it. So your data is stored and queryable without any modeling work on your part. Now, that doesn't mean it's great, right? It doesn't mean it's the model you want to end up with. But suffice to say, you don't have to stop the presses if somebody makes a change on the mainframe that lands in the topic that rolls out to your table. It's not going to break. Now you probably do want to make something nicer out of it, because there is a better design somehow. So there is some data modeling that goes on and some transforms that go on. But then once you're done with that and you've got some rich document in MongoDB, it kind of is your API. So think of that graph of what it took to build that API, and in Mongo you just say, here's the document, right? It's the whole domain. And so so we got this. You're repeating this cycle. Remember, you're trying to move forward. You're trying to offload a system from the mainframe. So you're trying to take in all the details of something, but that system is not static. It's constantly under change. You're responding to things like, new state legislation that changes some, discount structure or something. That is constantly under change. So you have to not only be able to move forward and do this offload, you have to absorb the constant change that's coming in that system as well. So the point being, this cycle has to be way faster than any change cycle on the mainframe, or you're going to be, the one with the stale data, with the stale app that's not caught up, that, we know the change went in last week, how come we can't see it now? So think about that with regard to time to value. Because it's, we all live in this world that we fight for funding and we fight for resources, and how do we get there with it? A couple of pitfalls, part of the lightning sand, right? That you want to make sure. If you come in with a driving force, right? People say MIPS cost is our number one problem. We're definitely going to, we got to reduce our MIPS cost. And so you say, okay, you know what? We're going to offload this into an identical relational structure. And so you build this thing on the other side in some other database, Postgres or Oracle or whatever you want to build it in, and you say, okay, now we've got it in there. We can move the data one-to-one, no problem. Once again, that data is constantly under change. So now you've got whatever the structure was that was there if it even supports it, right? You know, you might not even be able to support the data structure, but either way, you've got to build all that DDL. You've got to build whatever stored procedure. You've got a whole bunch, and this is just to keep everything the same, right? You've got a whole bunch of work ahead of you. So maybe cost, certainly it's a big factor. You want to take it into account, but don't let that be the only thing that drives your design on the other side. Same thing, if you're only interested in performance, you put in a cache layer. Does that help you with the next stage? And so what we want to look at is you know, where we're going in this mainframe journey. So let's look at an approach to this. So I've got a maturity model here. And one of the things to think about is people do have a goal that they want to retire some aspect of the mainframe. Maybe it's a pipe dream, right? Maybe we'll never get there. But what happens is you don't want to get 2 or 3 steps into this and have to change your technology on the other side. You don't want to have to get there and say, well, we only put in a cache and we really can't handle transactional workloads, right? You want to be able to grow with that until your external system can fully replace what you're doing on the mainframe. Once again, there's 32,000 procedures in the CICS region. You're not going to know which one does what. So but we want to be able to graduate from level to level. So in this model here, we've got, you know, we offload that stuff. Let's take that first case, right? We've built a cache with the exact same data structure as we had on the mainframe. We've got this operational data store. We can definitely buffer some of the reads. That's nice. But then what happened is the business had features, right? We've got a backlog, and we want to deliver some of those features. And maybe that requires integrating multiple data sources. And so to get those data sources together, we need an enriched operational data layer. And to do that, we've got to combine some things. And so now we're moving beyond what we had in the mainframe. We're changing that data. We're trying to offer a better user experience on the other side. On the other hand, there's a lot of stuff that gets saved in the mainframe, right? The legacy system that calculates, you know, balances or whatever in a bank, it doesn't care about people's email address. But now that we have digital, you know, experiences attached to the mainframe, they needed a place to store the data. They're persisting things like session data back to the mainframe. They're doing stuff like this. They're putting data in there that is not part of the critical legacy calculations, and maybe we can offload that. So maybe it's still needed for reference, but maybe we get to write it into the external system first, and then, you know, write it also to the mainframe. But now we've got better consistency so that you don't have to go back to the mainframe for the read. Same thing, we can move this into the transactional point where now we have the guarantees that it's saved, and that we, you know, it becomes the trusted system and eventually the system of record. But you've got to be able to walk this journey without having to, like, you know, change your shoes in the middle of the race. And so that's why your offload technology is so important. I've mentioned most of these, so I'm just going to walk right by them here. But the, you know, the importance of change, and then data movement. It's not MongoDB's gig, but let me tell you, unless you get that part secured, your mainframe offload is in serious jeopardy, right? You have to have some system that can do change data capture, that can get those changes out in near real time, because the alternatives are what everybody's doing now, right? 80% of your MIPS is batch processes. So, and most batch processes are like 80% inefficient. So they're overlapping the data. You have a whole bunch of deduping and stuff, and you don't want to be stuck with that. You want to have your external system have the data integrity that people, you know, will trust it, that people don't say, hey, this is the wrong stuff. So let's look at where MongoDB fits into this, because I wouldn't be up here if I didn't think it was a good one for that offload system. So this is one of those things that I hear a lot. particularly upsets me, and that is, it's great as a cache, but not suitable for transactional workloads. And I want to dispel that myth. We've had ACID compliant transactions for 6, 7 years now in MongoDB, and the original document model and part of the deal with having a rich document structure is it meant that that was an ACID, that was a atomic save from the get-go, from the beginning. The saving of a single document was always atomic. And if you think about one of the reasons ACID transactions are so important in a relational database is because you've got all these related tables that you have to get locks on in order to save your transaction. And if you don't have a bunch of related tables, it's just not as important. But it exists, and people might need to work across multiple documents or multiple collections, and that's why we have ACID compliant transactions. Another thing to think about on this, and I didn't get it on the slide here, is the distributed nature of MongoDB. We offer high availability, resiliency, and near infinite scalability with our sharding. So mainframes hold a lot of stuff. We've got to hold a lot of stuff. Mainframes have terrific I/O capacity. We have to have terrific I/O capacity. You have to be able to beat the system you're replacing, or at least in chunks, right? So the document model at the core of MongoDB is this idea that a rich document that represents something like your business object is the simplest way to get at your data. So, but what this does is it's a big gain in efficiency when you go to the document model. And I love, were I having my own laptop here, you'd be seeing more code than this. But if you just look at the differences, right? If we take a simple, 6, 7 table thing in this little claim example here, and you want to get all the SQL to get that claim, it's not just that one paragraph, right? It's going to be a lot more than that. And in MongoDB, it's a single operation. That's also a single operation on the disk. It's a single IOP to grab that document. You're having to touch every table and every foreign key index to find your way into those other tables. You're making dozens of touches of the disk for every touch to get the document out of MongoDB. That efficiency, when you start moving into billions of documents, makes a huge difference. On the other side of it, when you're writing, the same thing holds. If you're a developer and you're working in Java and you've got some map object that's JSON, it's a rich thing, that's what came in from your API, that's the payload you got. You've got to deconvolve that entire thing to go save it in your database, and maybe your repository component in Spring Boot takes care of a lot of that, but the minute you get to production, you say, whoops, we better optimize. Now you're writing the SQL anyway. In MongoDB, first off, I've included a bit about the transaction in there. When you write a transaction in MongoDB, it looks just like a transaction you'd write in any SQL database. But once again, you've got efficiency on your side. That transaction on the SQL side actually goes off the page. And so I love this little clip here, which is to say, a lot of people say one of the reasons that they're nervous about going to MongoDB is they have to learn a new language and they have to do it. But wouldn't you rather learn a language where you write one-line queries than multi-page queries? So I'm cribbing right back to Mr. Runkle's presentation because I love this slide. But it's akin to the idea, if we have to break apart the pieces of information that represent a single business object, it's a bit like taking the car apart. And so you've got all these components, you'd have to store it for those components. And every time you want to get that business object back, you have to retrieve them all and assemble them in order to show that. So Jay's already explained this, but when you ask for a business object in MongoDB, like a car, then you're going to get the whole car. And moving on. So what I'd like to do is talk a little bit about this little insurance policy type model. And what we're doing here is consider our offload project. Everybody knows that insurance companies are very acquisitive, right? And every time you make an acquisition, you get a new policy system. And so there's one for every acquisition. And so we went through and we were good doobies, and we made a model in our offload system here, and we've got our little policy domain here. And as you can tell, it's greatly simplified. Even if you pull up a chord and look at a policy domain, it's hundreds of tables. But in this one here, there's a product that's offered, and some plan sponsor negotiates, and they say, okay, this is the coverages we'd like, and that gets baked into a policy, and in this very simplified system, they just turn all those coverages into a paragraph and drop it into a description in the policy, and that's how they store the actual policy that the holder has, right? And so we got that offloaded, and we're doing fine. We're patting ourselves on the back. And then we're like, okay, well, let's move to the next policy system. Well, in this policy system, which we like better, it has the concept of a version of each product. And so the coverages can vary with the version of the product. And it also goes further and says, let's take and include those coverages, copy those coverages to the policy as they've been negotiated by the plan sponsor, so we can actually query in depth what those coverages are and get them. So in order to do this, we have to make some changes, right? And notice I've narrowed the universe a lot on this. So we're literally changing 2 tables. You know, the idea that you'd bring an entire policy system over and only have to make 2 table changes, you just, go off and get your drink now and say, we're good. I only had to change 2 tables, right? But just for scale, to look at what that means, if I'm going to make those changes in my SQL database, right? This is that cycle time. This is that time to value. This is what you have to do every time you're pulling this together, is you've got to be able to make these changes. And many of these changes come with downtime, right? You're going to have to schedule a window so you can make these kind of changes in order to get this stuff out to your customers. So we got DDL, we got to add the table, we got to add this other table, we got to add these version IDs, create some indexes, make sure our primary and foreign key indexes are there, sequences, constraints, the whole deal. What it ends up being is a lot of DDL, right? And I only could paste a page on here. That little bar up there shows you how much of the page I'm showing you, right? That's a lot of DDL, and I'm adding 2 tables in 3 or 4 fields, and then doing the DDL to copy the data, right? That's a lot. So what if we did it in MongoDB, right? When we built our first offload in MongoDB with the original system, we took advantage of some embedding. So what we did was we embedded the product coverages in the product. Pretty simple. It makes it easy. A single document has the product and all the coverage. In the same way with the policy, what we did was we put a thumbnail of the plan sponsor in there, so we did just enough information to make it good. And then we embedded a bit about the holder, but there's still a member document somewhere else that has all the details. But that way, if we just wanted to show somebody a list of their policies and a couple of things, we could grab it in a single document. But now, in order to migrate ourselves to this new policy 2.0 thing, we're making some changes, right? So we're going to add a version object. Sorry, that diagram's wrong. That version is an object in product there. And then on the policy side, we're going to add the coverages. It doesn't look a whole lot different, does it? These changes are pretty easy to make. So what it means over here, and remember the other thing, we can make them with no downtime. We can migrate these. We could even be completely lazy and say every time you encounter, in your code, every time you encounter a policy here, convert it to the new format and fix that little document version there and say it's now a 2.0 document that includes all these new changes. What it means there's two ways you can do things, right? You can do it in a blocking fashion. You can say, hold on, I'm gonna fix everything, and then I'm gonna let you use it again. Or the other thing, you can do it in a detective fashion. You can say, oh, these changes that come in, we're going to pick out the things we need from them, and we're going to add them in incrementally so that people can take advantage of it without things in downtime. And so what this turns into is a few changes, DDL, no DDL, right? And we've got to add the version, so we know what those changes are. But what it turns out to be is this. There's a single aggregation, and in that aggregation, in querying the data out of each product, the coverage data out of each product, we instantiate the structure in the schema of the policy that holds those product coverages in one motion. That's all that DDL, and that's all that DML in that single aggregation. We add a few indexes, update the version piece, and we're there. So, in conclusion, it's a lot easier, right? And remember, you have to be extra fast in your, this is just giving you more detail. So I've reached my little time limit here, and I did want to leave some room for Q&A, but I'd like to offer you all the opportunity to go grab a drink and then come back and have Q&A. So then I'm not holding you up from getting a beer. So, or you can ask questions directly. But let me give you my little summary here. Flexibility is absolutely critical to this. You cannot control all the changes feeding into your mainframe system. But what you can control is your ability to absorb those changes in your offload system. So flexibility is of paramount importance. There is, if you have the same change process, the same DDL, the same modeling, the same everything that it takes to make a change on your mainframe, on your offload system, you're doomed, right? Because you're one-for-one effort. So now you've just doubled the effort of making a change because you got to change it on the mainframe, then you got to change it on your offload system. Unless you can beat that, you're never going to get ahead. So that's why flexibility is so key. And then that capability of growing, right? You want this system to evolve. You want to be better. You want to, it's not just a matter of, hey, we got the MIPS cost down a little bit. You want to give the business the features they want. They're just upset about the cost because they haven't seen the other things they want to complain about. And then the other thing is that once you'd have this offload system, you can't have scheduled downtime. You were promising them something better than the mainframe. Mainframes are pretty darn stable, right? I mean, they do a good job, but the systems on them involve downtime for scheduled downtime, not usually things crashing. But you got to have that resilience on your offload system. So let me wrap it up there, and I'll put up my little thing here to rate the talk, and then I'm happy to take questions. Or you can just go grab a beer and leave me alone, or what? Let's see. Yes?
In the context of the two, I actually have two questions. One of them is taking this ORM in the relational model.
That's right.
Stuck this guy in there and said, oh, that's just like the big guy, it's got this.
Yeah.
But it's really not. I mean, but I was wondering, had you in the context of your endeavors encountered the ORM?
Oh,
what would you do? Like,
this portion of gray hair is hibernate. So yes, ORMs are a fantastic Band-Aid on the relational model because you can do so. I was a Rails guy, so you can rake DB migrate and get something here and bring it through. But invariably, once you reach production and you have high performance workloads on there, you are bypassing what the ORM does because it's going to have very simple rules. And they tend to be, the model equates to a single table. It wants to look up in a single table. Then you say this model belongs to that and has some of this. And
slugging this memory object around all over, in this little teeny little bit.
That's right.
I think that's the reason not to go there.
Yeah, so the ORM is a fantastic tool for development, and it gets you through a lot of that. But then what happens is invariably you outgrow your ORM. Yeah.
Many times.
Yeah, that's right.
And my second question was
Yep.
dealing with as a, so you got this your new version of the mainframe, your new version of the document object model.
Yep.
But then how do you integrate this as a? They always want to run a policy when it was as of 2 years ago, or 3 years ago, because you're running a claim that's, old.
Yeah, well, that was part of the idea with the why we liked our new model better was we were able in this model to say, the policy at the time of issuance had this coverage. Yeah. Yeah, so we knew about it.
Got it. Okay.
Yeah.
Thank you.
Oh, good. Yeah.